Okay, so the final thing that we're going to do here before we take our quiz is talk about odd and even functions, or possibly a case where they are neither of the two. You'll see here on the screen that there's a little bit of extra information than what's on your guided notes, so you may want to pause this for a minute and jot down what the tests are for finding an even function. The first thing, which is probably the most important, is the end behavior has to be going in the same direction. So if you look at the first graph to the left here, you notice that our end behavior, both of the ends are heading toward negative infinity. They're both going down, so that passes the first test of whether or not it's an even function. The second example also has end behavior that is going in the same direction. They're both going to infinity. So both of these graphs pass test 1. The second test is that if we reflect the graph over the y-axis, we need to get the exact same graph. So let me put a dotted line here where the y-axis is, right about there. Let me move that over a little bit. And the question becomes, if I reflect over that, will I get the same thing? And the answer is yes. Another way that you can, kind of figure out whether or not it's going to reflect the right way, you can kind of measure the distance of any of the points. Let's say, they have a red line here that kind of also does that for you. But let's say I pick this point here. If I look at that distance, if I went ahead and reflected that point to the other side, it would be right there. So you know that it's going to be the exact same distance, therefore it's going to reflect. So this is an even function. The second example actually ends up not being an even function, because if you were to reflect over the y-axis, you would not get the exact same graph. It would be helpful if I actually drew a vertical line. There we go. All right. So let's pick a point on this graph. Let's say I just pick, I don't know. Really, you can pick any point, but the idea is this. If I were to reflect this over the y, this thing's going to look, something like this, and you see that you don't get the exact same graph. It'd be totally different. Okay? So, let's take a look at odd tests. Oh, by the way, in this case, this would be a neither. It's neither even nor odd. Okay? So if we're looking at odd tests, in this case the end behavior needs to be going in opposite directions. So you'll see end behavior here going to infinity, end behavior down there going to negative infinity. Same goes with the second example down here. So both of these pass the first test, which is end behavior going in opposite directions. The second test is that if you rotate the graph 180 degrees, you need to get the exact same graph. Now remember, 360 degrees is a circle, right? All the way around. A full term would be 360. So 180 is basically turning this thing upside down. And if you watch as I rotate this graph, if I rotate it essentially upside down, you see that I get the exact same graph. Okay? If you look at example 2, though, when I rotate this thing upside down, I do not get the same graph. You see how where I have my arrows, it doesn't match up with my graph. Okay? So you don't get the same graph, therefore this is a neither. You can also judge this by looking at distance of points as well. You see on this picture that, if I pick a point on the graph here, and then I flip this thing upside down, that point would be a lot closer to the axis here than it was up here. Okay, so that's another way you can look at that is, those points, they would have to be the exact same distance from the axis, and they're not. Okay, so essentially if it's shifted up or down off of the origin, your origin is right here. If it's shifted up or down, an odd function it's going to be pretty much impossible to have it to make it odd, okay, for it to be odd. So, and And that's that.